Hey everybody, Mr. Piercy here, and what we're going to be looking at in this video is simply a review or a recap, however you want to think of it, of the investigation that you were doing in class for showing where the midpoint and distance formulas come from. And again, we're doing these investigations because I think it's pretty important as a high school math student, not only to see how they're used, but to see where the formulas, where the properties come from in the first place. So we're going to be doing a fair amount of these lessons throughout the year. I'm not going to do the whole investigation. I'm going to just kind of get to the, stuff that really is important. So let's take a look and see what we have here. The midpoint investigation gives us a point P at -7 and -6. And then I have point Q at 5 and 8. So Q and P, and we got something like that. And so what we're doing, one of the things that your investigation tells you to do is to take your straight edge, draw some dotted vertical lines between your 2 points. And when you're tracing this stuff on your patty paper, so that way you can fold it, when you fold it so that way the vertical lines lay on top of each other, you wind up with this dotted vertical line that would be where x is equal to -1. And one of the things that you're supposed to be able to recognize about that vertical line is that it's halfway in between the 2 dotted vertical lines that go through point P and Q. Well, then you're going to kind of do the same thing, but with some horizontal lines between our points. And when you fold your patty paper again, what you're going to see is a dotted horizontal line here where y is equal to a +1. And again, recognize that the crease, the horizontal line that you make when you crease your paper is going to be halfway between your dotted horizontal lines. And you see that they intersect. The horizontal and vertical lines that you made when you creased your paper intersect at the coordinate -1, +1. Now, the last thing that it tells you to do as far as folds are concerned, it says take the patty paper and fold point P so that it lays on top of point Q. And when you do it, notice what you notice is that it's right there, is in between where we folded it so that P and Q lay on top of each other. It's at the same coordinate where we got the middle point for the x's and the middle point for the y's when we folded it horizontally and vertically. And when it tells you to take the average of the x values and the average of the y values, and you see, oh, hey, that's where that coordinate is, we're able to draw the conclusion that the midpoint formula is simply the average of the x's and the average of the y's. Now, this is what you would see in any textbook, or if you Googled it or something like that, that's what they're going to show you. Another way of writing it that's useful in some instances is separately, where here I'm saying m sub x, where I'm using capital M to represent, I'm talking about a midpoint, and the subscript x says I'm talking about the x coordinate of the midpoint. So the x coordinate of the midpoint is just x1 plus x2 over 2, and the y coordinate of the midpoint would be y1 plus y2 over 2. And this is useful when I like to write my midpoint problems out like this. Whenever I have to find not the midpoint, but another endpoint. When I know an endpoint and I know the midpoint, I can use that version of the midpoint formula to find where the other endpoint is located. So there's that one. That's what we should have been able to conclude from our midpoint investigation. Now we're moving on to our distance formula. Now the distance formula here, okay, again I'm going to just kind of jump to the end here and kind of go through what the investigation should have allowed you to see. Well, we have two coordinates here, -4 and -3 for point H, and +8 and 2 for point K, and do like that. One of the things it's going to tell you to do on your investigation is to draw a dotted vertical line through point 8, or through point K, where x is equal to 8, I should say, and a dotted horizontal line through point H, where y is equal to -3. And what it's asking you to recognize is that, hey, we have a right triangle, where when I count from point H to the dotted vertical line, I got 12 units. And when I count from point K to the dotted horizontal line, I have 5 units. Well, because this is a right triangle, we can use the Pythagorean theorem to find the hypotenuse of the right triangle. So usually in 7th grade, students get introduced to the Pythagorean theorem, which they are able to recite as a squared plus b squared equals c squared. Well, for the purposes of what I want to do here is I'm going to say c squared is equal to a squared plus b squared. I'm going to just move, flip the formula around. Well, one thing I want you to understand is that anytime we square something, not only are we multiplying something by itself, but in this case we're using the numbers are representing sides of a figure. Well, if I square the length of the side of a figure, I'm not going to generate a side length anymore. I'm going to generate an area in the shape of a square. So I don't really want c squared. I really want to know what c is. What's the length of only one side? In this case, side hk. So I'm going to take the square root of both sides and do like that. So working here, I'm going to say the square root of 12 squared plus 5 squared will give us the square root of 144 and 25, which gives me 169 underneath the square root, and 169 is a perfect square, so I can say in this case segment HK would be 13 units long. Well, now what we're kind of moving on to is, all right, well, how can we take the information that we know with the right triangle and use it to develop a new formula called the distance formula? Well, let's take a look at our x-coordinates. We have a -4 and we have an 8. And we know between those, they should develop something that would be 12 units long. Because remember, the x-coordinates are what moves side to side. So anything that moves side to side corresponds to our x-coordinates. And from our ruler postulate, we can say that the absolute value difference between the x-coordinates, don't need that email notification there, sorry about that. We don't, all right, get back on track. The difference of the x-coordinates as the absolute value will give us the same length that we had from point H to the dotted vertical line on our graph. So that 12, that is what I substituted in for A in the Pythagorean theorem. So that means here the difference of the x-coordinates should be the same thing. And if I do the y-coordinates, I want to see, am I getting the same thing? Well, I have a y-coordinate at a -3, and I have another y-coordinate at a +2, and somehow they have to combine to give me a 5. So again, if I take the absolute value difference between them, I'll get the same thing that I counted when I looked at the graph from the point K to the dotted horizontal line. Well, the 5 is what I used to substitute for B, and if I take the difference of the y's, that is going to give me the same thing that I substituted into the Pythagorean theorem. So that means we can take the Pythagorean theorem, which was, let me change my colors here, so that way not everything is blending together. So we can take the Pythagorean theorem, which I wrote in the form of c is equal to the square root of a squared plus b squared, and I can take the difference of the x's, substitute it in for a, And I'm going to say d now for distance. So I can say, substituting for a, I can say x2 minus x1, and we still square it because that's what Pythagorean theorem said to do. Then I can take the difference of the y's and substitute that in for b. Oops, I said b and I wrote b. Get rid of that. Here I can say y2 minus y1 squared. Oh, let me clean that up a little bit. Squared. And now, if I take the numbers that I have for my x and y coordinates and I substitute them into the distance formula that I've written up on the board, we will get the same length from point H to point K of 13 that the Pythagorean theorem gave us. So here, the difference of the x numbers squared, the difference of the y numbers squared into this formula is what we call the distance formula. And this is a very powerful tool. What we're using here, the distance formula, is going to be used all throughout the year. So the two formulas that we have, the midpoint formula and distance formula, I will expect you to have them memorized. I will not be providing formula charts generally when it comes time for a quiz or a test. So you do need to remember what these formulas are. And we'll practice them a little bit later on as we go. But today, this video was simply to show us where the formulas came from, and moving forward, we'll see how they work. So until next time, guys, thanks for watching and take care.